Hi, let us introduce you to our security system. When it comes to your property, no one likes surprises. This is what our device is for. It is a remote environmental monitor, which makes accessing real-time data related to the environment of your choice possible from anywhere, under certain conditions as they will later be explained. With our device, it is possible to check that water levels, temperature, humidity, gas, and smoke levels are all within normal range. This means a more secure environment, associated with less severe cases of fire, damp, flooding, or gas leaks, as you will know right away if one of those situations arises. Here's how it works.
The system is able to detect changes in the temperature and humidity using the DHT11 sensor. As it can be seen in the code, the function measure environment is used to determine the temperature in degrees Celsius and the humidity in percentage, as seen in the security user interface. The MQ2 sensor is able to sense the concentration of different types of gases, among them smoke. Our system will warn the user about the presence of smoke. For this, a threshold, as seen in the line 104 of our code, was used. However, in the user interface, a value of 0 represents the absence of smoke, while a value of 1 its presence. Additionally, the passive buzzer and the red LED will turn on. For water level detection, the output of the sensor was not linear. Therefore, we decided to implement a more intuitive way for the user to understand the threat level in case of flooding. This was done by using LEDs and different thresholds. If there is no water detected, all the lights will remain off. A low water level will cause the green LED to go high. A medium level will cause an additional orange LED to go high. Finally, a high water level will cause the active buzzer to be activated along with the red LED.
The data recorded by the Arduino is sent to the Pi in real time via serial communication. The data is processed by the flow-based development tool Node-RED, which saves the data to a given directory, generates a dashboard to display the data in a user-friendly interface, and triggers a broadcast email to inform the user of sudden changes in the security system environment. The data is saved to a CSV file in a shared directory created using a Samba server. Providing the security system is connected to a local network and a network drive is set up, the raw data saved on the Pi can be accessed from any device and operating system in the local network.
To better understand our system in action, we created a scaled-down environment of where the system would be used. You can see that all sensors and alarms were implemented within the scaled environment itself. Now to demonstrate the first of three features, the water level detection, more specifically the detect signs of flooding in a designated area. As shown previously, the sensor is placed vertically above the ground and attached to the wall, as well as red, yellow, green warning light system just above it. The simulation began by pouring water over the environment floor, observing the immediate activation of all three warning lights due to the way that water was poured on the sensor. In reality, the flooding would occur much more gradually, so a slower change from green to orange to red would be observed, followed by the repetitive pinging alarm heard in the video. On to the second feature now, smoke detection. In this simulation, a source of smoke is placed in the room. In this case, we set a light to a model book, and the resulting smoke is detected by the sensor located on the ceiling. The alarm system is activated shortly after, noticing that it has a different alarm system sound to the water level one, so the hazards can be distinguished, and this alarm is repeated until the system detects no smoke anymore.